All right, so hopefully you guys tried the example problems for this section. So let me see what we got here. All right, so basically the shadow of the building is 12 plus 6, so we have 18, and it corresponds with the shadow of the daughter, or I guess this is a different problem, the height of this rectangle. So 18 goes with 12, and let's see, 32, which is if we were doing the shadow problem, this would be the height of the building, corresponds with the height of the daughter or whoever. All right, so then if we cross multiply, looking for my calculator, so if we multiply 32 times 12, we get 384. 18 times x is 18x, so we're going to divide both sides by 18. So x is equal to 21 and a third. 21 and a third. Okay. All right. Does that look right? 18 to 12 and 32 to x. Yep, that looks right. All right. Number 3, similar triangles. It says, use the similar triangles process to determine the lengths of the missing sides below. Round your answers to the nearest 10. All right, so then we can say that 8 corresponds to 3. 8 corresponds to 3. And then we'll say 21 goes with A, right? A. The letter A. So then if we cross multiply, 3 times 21 is 63. 8 times A is 8A. So we're going to divide both sides by 8. And it's almost 8, but not quite 8. So it'll be 7. And 7 times 8 is 56. 56, so 7 left over. So we could say 7 and 7/8, or we could say 7.875 would be 7.9. 7.9 rounded to the nearest tenths. All right, so then we have to use 8 to 3 again. 8 goes with 3 and 18 goes with B. So then we cross multiply. 18 times 3 is 54. 54, 8 times B is 8B. So we're going to divide both sides by 8. And 54 divided by 8 is going to be about 6.8, 6.75, or 6.8 centimeters. All right, how'd you guys do? And then we have the bottom one. So we have 12 goes with 5. Y goes with 2. So 2 times 12 is 24. 5y. So 24 divided by 5, 24 divided by 5 is going to be 4.8. So y is 4.8. And then we can do 12 to 5 and x to 8 goes with x. So if we cross multiply, we get 40 equals 12x. Divide both sides by 12, and x is 40 divided by 12, about 3 1/3, or 3.3. So this is about 3.3. All right. The next page. Now this triangle has not only shrunk, but it has flipped and rotated, because you see, if this looks almost like a right angle, correct? Well, that right angle, you have to think of this right angle. So when you're comparing sides, 36, this longest side has to go with 11. So I hope that didn't trick you guys. 36 goes with 11. which means 24 goes with, wait, hold on. All right, let's see. We need the lengths of the missing sides. So if I flip this thing up, back up the right way, here's 11 and 4.5. 4.5 is going to be right here. Right? And 36 goes with 11. All right, so we're actually missing two sides, aren't we? So we can call this side X and this side Y. So we can use 36 goes with 11 and X. Let me get rid of this. Oops. Whoops. All right, let me just redraw it. I'm sorry. All right, so here is our right angle. Are you with me? Here's our right angle, and here's our right angle. So I'm trying to make sure I put corresponding sides together. So we know for sure that that 36 goes with 11, and then the shortest side is 4.5. So let's not look at this. Let's look at this. So that means we're missing this leg of this right triangle and this leg of the smaller right triangle. So we have to solve for both of them. All right, so the only two that correspond that we have both of them is 36 and 11. So 36 goes with 11, and then 24 goes with Y. So then we're going to cross multiply 24 times 11. 24 times 11, oh my goodness, is 264. 264 equals 36Y. So we're going to divide 264 by 36, and we get 7 1/3. So Y, which is this right here, is 7 1/3 or 7.3. And now we want to know what X is. So once again, we're going to use 36 over 11, and this time we're going to use X over 4.5. So 36 times 4.5 is 162, and 162 divided by 11 is about 14.7. So X is about 14.7. So hopefully you guys got those right. And then finally, the application problem. Sandy wants to know how tall the flagpole is near her school. One day she decides to find out. She measures the length of the flagpole shadow. The shadow is 15 feet. So the flagpole is tall. And then she measures her shadow. Her shadow is 5 feet. Now, how tall is Sandy? Sandy is 4 feet 8 inches tall. So that's not 4.8. Since there's 12 inches in a foot, it's 8/12. 4 and 8/12. Well, we can divide 8 and 12 both by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. Well, now that's a non-terminating decimal. So she's 4 2/3 feet tall, right? And we don't know how tall the flagpole is. So we don't want to turn this into a non-terminating decimal because you never want to multiply by a non-terminating decimal. So let's go ahead and use our mixed number. So we're going to say that X corresponds to 4 2/3. And then we could say that 15 corresponds with 5. Well, one easy way to think of this is if 15 divided by 5 is 3, then when we simplify this fraction, it would also have to be 3. Do you understand what I'm saying? Because these are proportional, which means they're equal. So, you know, we could I don't know the best way to do this, but well, I do too. Since 5 times 3 is 15, then let's just multiply 4 2/3 by 3. 4 2/3 is equal to, let's turn it to a mixed number. So 4 times 3 is 12, plus 2 is 14/3. And then we can multiply that by 3/1. Well, look what happens. The 3's cancel. And 14/1 is just 14. So really, that's the easiest way to do that problem. If 15 is 3 times 5, then this side has to be 3 times 4 2/3, which is going to be 14. So 4 and 4.66666 times 3 is about 14. So anyway, that's the easiest way to do that one. All right, so we're moving on. Now we're going to talk about perfect squares and square roots. Let me move this. All right, the square root of a number is that number which, when multiplied times itself, gives the original number. On your calculator, this is what you're looking for. This symbol is called a radical. It's a radical sign. However, if you guys just have the add, subtract, multiply, and divide, I'm not sure if you have a radical symbol on your calculator, but you might. Some of the simple calculators do. So this basically, you say that this as the square root of 16 is 4. And the reason the square root of 16 is 4 is because 4 times 4 is 16. So it's asking what number times itself is 16. Well, since it's a whole number, the square root of 16 is a whole number, that means that 16 is a perfect square. However, there isn't a number when you multiply it by itself equals 19. So that means that 19 is not a perfect square. So if you find the square root of a non-perfect square, you always get a non-terminating, non-repeating decimal. So the best way to do that is just to use your calculator and then round it. It says to obtain a decimal value for non-perfect squares on your calculator, you may need to change the settings under your mode button. Check your owner's manual for help if you need it, okay? If you don't see a square root button on your calculator, you might need to just grab another one, or you can pull up a calculator on a computer. All right, so the square root of 169, is there a number times itself that is 169? Well, yes, it's 13. So 13 squared is 169, which means the square root of 169 is 13. All right, there is no number. When you multiply it by itself, you get 31. So you're going to put that in your calculator. Square root of 31 is 5.5677, so on and so forth. It says to round to 2 decimal places. So my calculator says 5.567, so that 7 makes me turn that 6 into a 7. So it's about 5.57. And then the square root of 9, what number times itself is 9? That's a perfect square, and the square root is 3. All right, so then you guys try these. So try all the ones on this page. Pause it, come back, and let's check our answers. All right, so the square root of 225, that's a perfect square. So the square root is 225 is 15. The square root of 17, whoops, I turned my calculator off. Square root of 17 is about 4.12. It's not a perfect square. It's not a perfect square because 4.12 times 4.12 is not exactly 17. It's close, but it's not exactly. That's why it's not a perfect square. And then the square root of 324, I don't think that's a perfect square. Square root of 324 is 18. Oh, it is. It is a perfect square. So 18 squared is 324. All right, try using without your calculator. So what number times itself is 1? 1, 2, 3, 4, 5 squared would be 25, 36, 49, 64. Then we have 81. Square root of 100 is 10. 11 squared is 121. And then square root of 144 is 12. Without using your calculator, place these each of these on the following on the number line. All right, so 2 is not a perfect square, but square root of 2 comes between these two numbers, right? Which means the square root of 2 has to be between the whole numbers 1 and 2. So the square root of 2 comes somewhere between 1 and 2, square root 2. About right there. All right, square root of 11, find it up here. Well, 11 comes between 9 and 16. So the square root of 11 has to be between the whole numbers 3 and 4. Somewhere between 3 and 4, we will find square root 11. Square root 40, well, where do we find 40? Between 36 and 49, which means the square root of 40 has to fall between 6 and 7. Probably, I don't know, maybe a little bit closer to 6. So there's square root 40. Square root of 60 has to be between 7 and 8 because 60 falls between square root 49, square root 64. So between 7 and 8, we'll find the square root of 60. And then finally, square root of 99 is going to be really close to 10 because 99 is so close to 100. So over here, really, really, really close to 10, we're going to find the square root of 99, although it's an imperfect square. Or I should say a non-perfect square. All right, so then it wants us to use our calculator. So you guys do this with me. Go ahead and pause and you guys do this, please. Tenths, hundredths, so that would be 1.41. So this will be 3.31. Square root of 40 is 6.32. Square root 60. Ooh, I gotta sneeze. All right, and then square root 99, really, really, really close to 10, 9.9. Okay, oh, hundredths, whoops. Oh, I did them all but that one. All right. All right, so the reason we're talking about perfect squares is because the Pythagorean theorem uses squares and square roots. The Pythagorean theorem is a way how to find side lengths dealing with right triangles. So anytime you have a right triangle, the side lengths have to follow the Pythagorean theorem. So all right triangles have two legs. So the two legs of any right triangle are considered the letters A and B. And then across from the right angle, which is the longest side of a triangle, is called the hypotenuse. Hypotenuse is always across from the right angle, and it's always the longest side. And it must be the letter C in the Pythagorean theorem. So basically, someone figured out a long, long time ago that when you have a right triangle, if you get the two sides, leg lengths, you square them and add them together, they equal the hypotenuse squared. Okay, for example, let's say letter A is the number 3, letter B is the number 4, and letter C is the number 5. Woo. So let's see if we can plug this into this formula and see if this is true. Well, if A is 3, 3 squared plus, if the letter B is 4, 4 squared, it's got to equal C squared. So what is 3 squared? 3 times 3 is 9 plus 4 squared is 16. That has to equal 25 because it's showing us this is a right triangle. So is this true? Does 9 plus 16 equal 25? The answer is yes, it equals 25. So that proves that those dimensions create a right triangle. My dog's barking. Because it follows the Pythagorean theorem. When you do the math, if the two sides squared and added together does not equal the third side squared, then it's not a right triangle. It can still be a triangle, it just isn't a right triangle. All right, it says use the Pythagorean theorem to find the missing side lengths for the triangle given. Now, remember what I said, the hypotenuse must be considered letter C, and in this situation it is. It doesn't matter which are A and B, it's just the two shorter sides. So we can use 12 for A and 7 for B. All right, so 12 squared is 144. 7 squared is 49. And those two added together has to equal C squared. Well, 144 plus 49 is equal to 193. Now, C doesn't equal 193, but C squared does. So how do we find out what C is? Well, the only way to get rid of C squared is to do the opposite of squaring it, which is to find the square root. So the square root of C squared is C. And to find what the length of C is, we have to find the square root of 193. So the square root of 193 is about 13.89. So C is about 13.89. And that's how we do it, by using the Pythagorean theorem. All right, let's look at example 13. Now this time we're missing the letter A. So this has to be letter B because it's the other short leg. And then C has to be the hypotenuse, which is the longest side. So this time A is our unknown. So we're going to leave it A squared plus, now our B is 3.8 squared is equal to 17.3 squared. We still don't know what A is, but we know that 3.8 squared is 14.44 is equal to 17.3 squared is 299.29. Now we want A by itself, so how do we get rid of plus 14.44? Well, the opposite of adding is subtracting. So we're going to subtract 14.44 from both sides. That goes away. A squared is equal to 58482. Now that's not what A equals, that's what A squared equals. So how do we get rid of A squared? Well, the opposite of squaring a number is finding the square root. So those cancel each other out. So we're left with A is equal to the square root of 284.85. And A is about 16.88 meters. And that's how we do that. All right, it says you try. So you guys are going to do 14. You're going to do those 3 problems and then come back and check your answers. All right, so number 14, we're going to use 23 squared plus B squared equals 62 squared. I'm going to turn my light on. My calculator is getting hard to see. All right, 23 squared is 529, and 62 squared is 3844. We want to have B by itself, so we're going to subtract 529 from both sides. So B squared is equal to 3844 minus 529 is equal to 3315. And to find B, we're going to find the square root of both sides. So B is equal to about 57.58 feet. All right, and then this one over here should be a whole number, I think. So let's find out what y is. So y squared, they're telling us this is a right triangle, plus 12 squared is equal to 15 squared. Y is 15 letter C. It's the cross from the right angle and it's the longest side. So 12 squared is 144. 15 squared is what? 225. Ooh, that was ugly. We're going to subtract 144 from 225 minus 144 is 81. And then to find y, we find the square root. So y is equal to 9. Y is 9. Y is 9. Okay. All right, this is our hypotenuse. This is letter C. So we're going to do 21.3 squared plus b squared is equal to 42.8 squared. So 21.3 squared is 453.69. And 42.8 squared is 1831.84. So we're going to subtract 453.69, 453.69. So b squared is equal to 1,378.15. And then finally, we're going to find the square root of both sides. And b is equal to about 37.12. All right, examples 15. It says in NBA basketball, the width of the free throw line is 12 feet. A player stands at one exact corner of the free throw line and wants to throw a pass to his open teammate across the lane and close to the basket, player 2. If the other teammate, player 3, heavily guarded, is directly down the lane from him, 16 feet, how possible is his pass, how far is his pass to the open teammate? Fill in the diagram below and use it to help you solve the problem. All right, so this is player 1 right here, right? It says the width of the free throw line is 12 feet. Player 1 wants to throw a pass to his open teammate across the lane and close to the basket. So he's going to throw it here. If his other teammate is directly down the lane from him at 16 feet, so does this mean this is 16 feet? Fill in the diagram below and use it to help you solve the problem. Well, if this is 16 feet, that means this side has to be 16 feet, right? And it wants to know how far this pass is going to be. Well, if you look at this, this looks like a right triangle. And it wants us to find the, what's it called? Hypotenuse. So since this is a right triangle, we can figure out the length of this diagonal. These are our legs of our right triangle, so we can use these as A and B. So 12 squared plus 16 squared is equal to our hypotenuse squared. So 12 squared is 144. 16 squared is 256. And that's going to equal C squared. Well, 144 plus 256 is 400. So 400 is equal to C squared. So what does C equal? Well, the square root of 400 is 20. So the answer to the question is 20 feet. There we go. All right. 2 trains left a station at exactly the same time. All right, so we have 2 trains. One train is going south, that's south, and one is traveling west. So they're both left The same starting point, one went down or one went south and one, oh my goodness. And one went west, right? When the southbound train had gone 75 miles, so this train traveled 75 miles, the westbound train had gone 125 miles. How far apart were the trains? So this train is here, this train is here. We want to know how far apart they are. Well, they made a right triangle. So we're going to do 125 squared plus 75 squared equals their length apart from each other squared. So 125 squared, ooh, 125 squared is 15,625 plus 75 squared is a big number as well, 5,625. That's going to equal c squared. Well, those two numbers added together is 21,250. And now to find what c is, we're going to find the square root of that big number, and we get about 145.77. Is it miles? Yes. About 146 miles apart. All right, letter B. TV screens are measured on the diagonal. Did you know that? If you have a 72-inch TV, it's not 72 inches across, straight across. The 72 inches is the diagonal. So straight across is actually going to be less than 72 inches. It says we have a TV cabinet that's 40 inches long and 34 inches high. How large a TV could we put in that space? Leave 2 inches on all sides for the edging of the TV. Oh my goodness. All right, so we have an opening and we have to leave 2 inches from all 4 sides to get give our TV enough space. So the TV cabinet, it's 40 inches long and 34 inches high. But if we want to leave 2 inches on all sides, that would be 4 inches short of 40. So 4 inches short of 40 is going to be 36. And if it's 34 inches tall, but we want to leave 2 inches off the top and 2 inches on the bottom, we can only use dimensions of 30. And then we want to see how big we could get into this space right here, right? So we're going to use 30 and 36 as A and B. So 30 squared is 900. And 36 squared is 1,296. So we're going to add those two numbers together, and we get 2196. And then to figure out how wide it could be, we're going to find the square root of that number. And we got 46.86. So about 46, you have to have a TV less than 49 square feet, or 49 in, what am I saying? 46.9 diagonal. And I don't even know what the dimensions are, do they? What are the dimensions of TVs? Are they every 6 inches? I don't even know. But anyway, that's the very, 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 very largest right there. The diagonal couldn't be more than 46.9. All right, it's 6 o'clock on the dot, and I think, yep, I think we just finished that. So that's cool. All right, so I am going to upload this to YouTube, send it to you, and hopefully if you guys have any questions or problems when you're doing your homework or your quizzes, you can email me or text me. And I will see you live Wednesday night. We're going to have a quick review, and then your test will be at 7 o'clock Wednesday. All right. Thank you, guys. Have a good night.